For problems like 14 and 16, we're being asked to make a graph of an exponential function. And since you don't have a lot of experience with these types of functions yet, you're going to have to start by plugging in some numbers. So I'm going to recommend that you always choose the same x values to plug in as we get started. Typically, we want a couple of negative values, 0, and a couple of positive values. These ones keep the numbers pretty small so that you don't have huge numbers to try to work with. And we're going to substitute those in for x to find out what the values are for y. I recommend that you don't start with -2 because it's a little confusing to start there. Let's actually start with 1. So if I do 3 to the first power, we know that that just equals 3. 3 to the second power is 3 squared, or 9. Now let's start working our way up the table. 3 to the power of 0. Remember, our laws of exponents say that anything to the power of 0 equals 1. And then we need to go to our negative exponents. 3 to the negative first power. Remember, our laws of exponents say that anything to the power of -1 means take the reciprocal. So the reciprocal of 3 is 1/3. And then 3 to the negative second power tells us to do two things. The negative part of the power tells us to take the reciprocal, but then we still have to square. So 1 over 3 squared is 1/9. So now we have some numbers to work with. So this exponential growth problem is going to go on the xy plane, and we're going to make a graph. So I'm drawing my axes. Let's start with the things that are a little easier to do, right? The point 0, 1 is right here. The point 1, 3 is right there. And the point 2, 9 is way up here. Now, if you think about the graphs that we looked at back in our note sheets, remember that growth functions looked like this, and decay functions looked like this. So we sort of have an idea of what to expect. This is clearly a growth function because the b value, the 3, is bigger than 1. Now, I know that on this left-hand side, it's getting really close to the x-axis, but it's not actually going to meet it. So I'm not actually going to try to graph 1/3 and 1/9. That's really hard. I'm just going to draw the curve in, and I know that it's going to come really close to this axis, but not run into it. So we're going to estimate a little bit on that side of the axis. And I'm going to label the points that I did graph accurately with coordinates, just like when we were graphing lines, we had to label points on the lines. So that's basically what you should expect your graphs to look like when you do problems 14 and 16. And the amount of labeling that I have here is the amount of labeling that I'm hoping to see from you when you make your graph.